Okay, Algebra 2. Today is evaluating and graphing polynomial functions. In order to do that, you're going to identify and describe the polynomials, evaluate them using various methods, and describe their end behavior. We're only going to get up to evaluating in this video, and we will do the graphing in class. So it's important for you to know what a polynomial function is. Polynomial functions are functions that have whole number exponents. Also, I should have probably put in that they're also real numbers, and the coefficients are also real numbers. No imaginary numbers allowed. Square roots are okay, but no imaginary. So we're going to learn about a couple different types of polynomial functions. These are the common ones here. If degree is 0, it's just a constant number. Example, same for degree 1, that's a linear function. You know what lines look like. Degree 2, we just finished that. That was quadratics. They have x squareds. Degree 3 are cubic functions, those have x to the thirds. Degree 4 is quartic functions, those are x to the fourths. And degree 5 or higher, just called polynomials, and they have exponents higher than 5 or higher. A lot of kids get confused between quadratic and quartic. Do try to memorize those. I'll ask you one or both of them on the test, and if you don't have the right vocabulary word, I unfortunately cannot mark that correct. Quartic kind of reminds me of quarter. There are 4 quarters in a dollar. That's how I remember it. Okay, so for parts of a polynomial, the first thing is standard form, and that's putting the terms in order from highest exponent to lowest exponent. Now there's also going to be, you'll see down here, a constant term. That's a plain number with no variables, so that would be the last part of a polynomial in standard form. So besides standard form of a polynomial, we have the degree, which is the highest exponent. Leading coefficient, I like to abbreviate that as L dot C. The book abbreviates it as A sub n. For degree, I like to abbreviate it as DG. The book abbreviates it as N. The leading coefficient is the coefficient in front of the highest degree term. So degree and leading coefficient are very closely related. The constant term is the plain number with no variable. I call this the constant. The book calls it A sub 0. It's a 0. It doesn't look like a 0. And then the last one is the type, and that would be gotten from the chart up here. If it's a x to the third, that would be a cubic. So here I have an example, and the first question I ask you, is it a polynomial? Which I'm going to go on to ask you a bunch of questions. The answer is going to be yes. Things that are not polynomials would have I, would have fractions or something like that in the exponents, which you can't have. So then give the following. The degree is the highest exponent, so the highest exponent we have is 4. Notice I'm not putting any variables with that, just the exponent. The leading coefficient is the number in front of that degree term, and the number in front of this degree term is 1. The constant is the plain number all by itself. That would be 3. And the type also is related to the degree. And if the degree is 4, you go back to your chart, you see that degree 4 is quartic, so we're going to write that on the line. And then writing it in standard form means I'm going to start with my highest exponent. I'm going to go down in order. If there happens to be an exponent that you skip, that's okay. Just keep going in order. So we have x to the fourth minus 2x squared plus 5x plus 3. And that's everything that I would ask you written out exactly like that. I gave you the book abbreviations in this side though because it's possible sometimes I interchange them, depends on how official I'm being, so you might want to know both abbreviations just in case you see it. All right, so the last part of the notes that you guys have is evaluating polynomials. We have direct substitution versus synthetic substitution. Direct substitution is super simple. You take an x value that you're given, you plug it in for x, type your whole thing into the calculator, it gives you the answer. Be very careful with direct substitution. The calculator is pretty smart. It knows order of operations. It knows everything that you might need for this evaluating. So what I do is I write out my entire function with the value of x in place of x. So something like this, it would say if the value was 2, 2x to the 4th plus 5 times 2 minus 2 times 2 to the 2nd plus 3. I write out my whole function with my x value in there, and I type that into the calculator. I use parentheses around it. I hit enter, the calculator tells me the answer. If you're going to try to do this piece by piece, you're going to get it wrong. So just trust your calculator, type that whole thing in correctly. Now the other part of evaluating is called synthetic, which is like fake substitution. It's going to give you the same answer as direct substitution without actually plugging anything in, which is crazy, really. It's going to use, I call it a large L, a big L, and coefficients to evaluate the function. Now the two important things for synthetic are that the function must be in standard form and that you need to use a 0 for missing placeholder, use a 0 as a placeholder for missing exponents and constant terms. We should probably put that in there. Okay, so I want you guys to write down these definitions that I just gave you, and then tomorrow I will have this second sheet and we'll go through that together.